Okay, good afternoon, good morning, and good evening from wherever you are joining us from. Welcome to a webinar here at HiveMQ, and thank you for taking the time to join us today. So the focus of this webinar today is going to be on powering intelligent data centers with a data-driven backbone. And we're bringing this to you in collaboration with Vertec, who's our partner. So before we jump into the webinar, just a few housekeeping items here. So this webinar will be recorded and you'll be able to watch this on demand on our YouTube channel. And we also do have a Q&A section at the end of this webinar. So make sure to drop your questions in the Q&A chat section. Don't drop them in the general chat section. That way we'll be able to get your questions easily. So yeah, my name is Kutsai Mandi Teresa. I'm a senior industry solutions advocate here at HiveMQ, and my role really, evolves around evangelizing and also educating our customers on industrial digital transformation, best practices, industry trends, and architectural approaches, and things like that. And as mentioned, we are collaborating with Vertec on this webinar, and for that, I'm joined by Ryan, who is a data center industry expert. So, Ryan, welcome, and please do introduce yourself to our audience and tell us a bit more about your role at Vertec.
Yeah, thanks, Kudzai. As you mentioned, my name is Ryan Crownover. I'm the director of digital plant at Vertec. Vertec, in addition to being a traditional systems integrator, we also have a digital plant division where we deliver software solutions to improve human and business processes on the shop floor. And that covers everything from including data centers and enterprise SCADA and large UNS backbone-like systems, as well as MES for manufacturing type work as well. So we span the whole gamut of anything you might call digital transformation with that team.
Awesome, thank you. All right, so again, before we dive into this session, so let me just take you through what to expect in this webinar. So this webinar is basically divided into two sections. The first part is going to be more of a panel discussion between me and Ryan, and we're going to try and understand from Ryan's experience what are the main challenges faced by data center operators, and talk about why traditional data management methods are sort of like no longer sufficient to help them cope with modern demands. And more importantly, we're going to talk about what are the solutions for building that data backbone or gaining that operational intelligence, and also go into the technology stack. And then the second part is going to be a presentation by myself. And the goal with this section is to take you through that data maturity path and show you the different architectural approaches, and also show you a reference architecture of what that architecture would look like in a real world scenario. And then I'm going to jump into more about real customer projects for some of our customers here at HiveMQ to give you a sense of how they are solving their problems and what are the outcomes of that. So let's just quickly jump into the session here with Ryan. So Ryan, let's maybe start by setting the scene for audience here. So from your work, with data center operators, what does that reality look like for teams trying to manage operations right now? What are the biggest pain points that you're seeing?
Yeah, absolutely. There's a few that have been popping up. One is just the massive scale. So as we move into GPU-based and a lot of AI data centers, and as we move into liquid cooling, there's just a whole lot more data points and active management that has to happen. And so the first and the biggest challenge is scale. Data centers already needed to be constructed as fast as possible. And now we're looking at systems that go from tens of millions to potentially even hundreds of millions of data points that need to be processed across, an entire portfolio that an operator might manage. And so I would say, the biggest factor there is just scale, and dealing with that.
Yeah. And then maybe just paint a picture for us on what's the cost of of inaction, or like rather, what is the the cost to not achieving that kind of scale? Is it downtime, energy waste, or something else? What do you see mostly there?
Um, as far as the impact of the scale,
Yes, yes.
yeah. So it's really into both the construction phase and then the active management of the data centers. So, with the life of data centers as they um, consistently need to be retrofitted with updated hardware and updated work, getting them uh, constructed and operational as quickly as possible is a huge motivator. When you're talking about tens of millions of data points for an individual facility, you're going to slow things down, or you're going to dramatically increase the cost if you don't have tools and techniques to make the development of these systems that manage all of that data scalable in the development phase, but then also in managing that data center as time goes on. You've got to have a user experience in your application that allows a very few individuals to be notified and alerted about things that are critical, and you need to roll up information in an effective way at a glance for those operators and the right people to be notified at the right time without just getting information overload. And that information overload happens, then it's worse than just having the downtime. Now you've got the downtime, but you can't tell what's wrong because you're drowning in a sea of too much information.
Yeah, absolutely. And why is it, difficult to achieve that, or to address those issues with the current, landscape of the data infrastructure, like the traditional methods that, data center operators have always used? Why is that not sufficient to sort of like help address this, kind of scale?
Yeah, absolutely. I think one of the biggest ones is, we need newer and more modern CI/CD type uh, tools that we can use to do the rollout. So a lot of lessons that the wider software industry has learned in how they deploy large scale systems. We've got to adopt those same things. Without those tools, if everything is just local server installed, and then you're managing all of those things manually, which doesn't enable you to one test and validate before deployment, which is really important if you want to go fast, and then also to roll out production really quickly and consistently as well. The other thing that doesn't work is traditional polling type methods, right? So this idea that I need to fully define all of my data structures and what the structure of my data and what maybe OPC UA is going to do, which is a fantastic protocol and does a lot of incredible things. But to centrally define that structure and then to have everything be polling based to go get data, um, the network bandwidth and managing all of that, it just isn't tenable, right? We need to push all of that down to the edge. We need individual devices that can report data on change. And MQTT in particular is a fantastic, protocol that enables a lot of that. And that's really giving us the ability to even have conversations about these systems that are in this, 100 million data point range.
Yeah, and I think polling is a big one, right? I know I love OBCA, of course. It's got its place in the stack, but with some protocols like OPCUA, when you try to read up to like just a few thousand or hundred data points, a lot of OPCUA servers, they just quickly are not able to cope with that kind of scale of the data. And then when you talk about data centers, the size of the data that you need to move is just not really sufficient with the poll mechanism. You've got like this fragile connection that breaks, and you're not able to really guarantee that uptime of the data that you need to really become a data driven company. But I'd like you to so maybe start to talk more about the solutions? Like when you sort of like as Vertec, when you sort of like come in to help, where do you sort of like typically start? Can you walk us through how you approach that problem? How do you solve that problem?
Yeah, absolutely. So one of the first things that in our approach that we take is to use graph-based data modeling, which, to put really simply, if you think about a data center, I've got the layout of the data center physically. So I might have a machine, I might have a server that might be in a rack, which might be in a row, which might be in a pod or a hall. Um, but then I've also got a power relationship. So I've got certain rows or certain racks that are fed by different power busways and tap cans and various different things. And then I've got, if I'm in a liquid cooled data center, I've also got the liquid cooled routing. And so all of those trees, I could draw a different map or a different graph of, I could look at it from the perspective of cooling. I could look at it from the perspective of power. I could look at it from the perspective of physical layout. And all of those matter, and different systems need need those different views in order to work. And so that's where something like what HiveMQ Pulse can do, and the way it can associate all of the different data that's going through um, the brokers and uh, gives the opportunity to build those relationships and put those in the system. So that's really important for helping define what our UNS structure is going to be. And that's also really important for any type of tools, any sort of data science that we're going to do, whether that's a tool that's going to actively manage the data center, because we've got to balance loads across different servers, or it's a system that we're just using, let's say, an AI tool or an ML tool to read what's going on and give us insights into what's happening. If we've built those graphical relationships, those tools inherently understand those types of data modeling,
Mhm.
and you get substantially increased performance.
Yeah.
And so that would be, that's kind of step one, is going there with
Yeah.
that um, graph-based data modeling approach. And you can then have your individual devices, the ones that are connecting to all of your equipment, that are actually publishing those MQTT messages. Uh, they can learn what they're supposed to be publishing from the definition of that data model. So we're still, report on change in our infrastructure, and we're still giving the devices the ability to publish into the UNS, but they're following the instructions from that graph model, and that really enables scale.
Yeah, I mean that's super interesting, and I think the industry is come to the realization that to really power industrial AI analytics, digital twins, all these use cases that really you know turn you into a data-driven company, you really need to have some form of graph representation, right? A graph data-based model, which is, as you mentioned, is what we also what we're doing with Pulse to be able to create that semantic graph to link all of your entities and different systems within your database so that you're able to provide that intelligence to higher level systems, whether it's in AI agents and things like that. But I would like to kind of like take a step back and sort of like paint a picture for our audience to say, how do you get to that sort of like having that data graph data model, like how do you connect, because I'm sitting here with the Modbus cooling system, a cooling system that exposes Modbus or PCUA or whatever legacy protocol. How do I get to that stage where I have got all of this data that is contextualized, ready to be consumed?
Yeah, absolutely. So, excellent question. So, you want to define what the definition of that UNS and where those things are going to publish. From there, you need something on the edge that's going to go do that Modbus polling, right? And so, product like HiveMQ Edge is going to enable that. Maybe you need to translate that, or add contextualized data into that you're going to publish into your UNS or your MQTT broker. And so something like Data Hub, or whether that's translation, into different protocols in different structures within your MQTT, or just adding that contextual data can accomplish that. But um, zooming out a bit, you've got to have that edge service that will actually pull to your device communications. More and more hardware manufacturers are starting to put MQTT publishing capable technology into their equipment, but we're still a long ways away from that being ubiquitous. And so you need that edge element to capture that data, have that publish that to your UNS. From there, you can start setting up the tools that are going to consume that data or add additional context to that data. From there, you can expose a lot of the information that's in that graph model as metadata alongside your real-time MQTT values, which is something that Pulse, HiveMQ Pulse would be an incredible thing to use to accomplish that, so that you can give that information to these other systems that are consuming the data.
Oh yeah, absolutely. I mean, it's a good point that you make. I mean, we in many cases when we talk about unified namespace or MQTT, hopefully our audience are more familiar with the term unified namespace, whereby, and I'm going to go into a bit depth around that, but we are really essentially decoupling your architecture, removing all of these point-to-point systems, and the sort of like first impression is that now you need to get rid of all your Modbus machines. You've got to buy some new machines that talk MQTT, which is not the case, right? So this is effectively an abstraction layer. It's a layer that you put on top of your existing system. You don't need to rip and replace anything. You're building that abstraction layer on top that allows you to grab all of the data from all the different systems, your cooling systems, your power systems, and then you're converting it into a format that is easily exchanged, or sort of like a common data format that allows you to exchange with all the other IT systems to create that unified data model, as it were. But I'll allow you for you to talk to us about what are the actual outcomes. Like, as you have worked with some customers, what example outcomes have you seen, and maybe talk to us about the timeline, sort of like how does it sort of like take to go through that project and start to see some ROI.
Yeah, absolutely. So there's some data center customers that we've got where without having this type of infrastructure, um, where their data center wouldn't even be possible to work. So I'll explain where that is that they have this UNS structure that we've built and we've implemented. It's MQTT, and all of the data is in there. There's real-time values on change being published through that broker. And they actually have another service that is managing loads across the different servers in the data center. And so in real time, it's measuring what's happening in cooling, it's measuring what's happening in power consumption, and then sending commands back through the UNS down to the cooling control systems to respond to the loads that are happening and the requests that are coming in to use compute power from the data center. And so this is at the scale we're talking about, a system with tens of millions of tags. To set that up and define it without using this UNS structure, and then to have this system have to pull data if you were using, let's say, a protocol like OPC-UA, wouldn't be sustainable. The amount of infrastructure you'd have to run just to pull that off would be really high. MQTT gives us the ability to actually pull that off. And if you didn't do that, especially for some of these higher compute data centers, they wouldn't function, which is pretty incredible. The other place where we've seen this and where it makes a difference is data centers that are, let's say, microgrid powered or self-powered. So they've got their own power generation on site that they're driving. And so there is actually conversation happening in a system that is managing both the power generation and the operation of the data center. And so all of that data is being combined into a single layer. And so there's one system that manages all of that. So there's one UI under a single pane of glass. I can manage the entire operations of that data center as opposed to having multiple systems that people have to learn and interact with. Which leads me to the other big outcome, which is the improved UX or the improved user experience for the people that have to interact with the system. High quality UX that really drives, that it's really truly intuitive for the users, decreases training, and increases the user's ability to solve problems with the application that much faster. And so if you can, again, that graph-based data modeling approach, you can now show that data in different ways in that UI in a way that's going to be natural for whoever that user is in the moment they're in. So if I've got a problem with cooling, I can look at the system from the cooling point of view. If I've got a problem with power, I can look at the system from a power point of view, or there's a physical leak problem, I can look at it from a physical point of view. And all of that is achievable at this scale for, a data center with 10 buildings, with rows and rows of servers per building, 50 or 100 million data points. And within 5 or 10 clicks, a user can get to any device and see any value and not get disoriented, which is just a massive operational benefit for the folks that are having to deal with the day-to-day operations of the facility.
Oh yeah, absolutely. And I think this also, in some sense, answers a question that Aaron dropped a question on the chat here. That I don't know. Maybe you want to address that one. Basically, Aaron is asking how large are the data centers we're discussing here? Could you kind of give us a sense of how large we're talking about?
Yeah. So we're these approaches scale down as much as they scale up. So I think that's really, we've done systems using this approach because it is effective for rapid deployment and iteration. We've done data centers that are 2 or 3 rows, right, with this approach, and that can be really, really effective. Like I mentioned, we're working on a project with a customer right now that is 9 or 10 buildings, and there's 10 to 30 rows in each of those. So the scale is quite large, and that's one site. We're also working on systems with customers where they've got brokers that are going across sites. Right, so they're unifying all of their data center operations into a single enterprise, view of what's going on, and then you can multiply from there. So this approach is effective at the full span of scale that we're talking about.
Oh, yes, absolutely. So, Aaron, for your other question on can you name any current clients you are working on, I'll talk about those, some real customer cases, although they're anonymized, but we're more than happy to share the names. You reach out to us. We'll talk to you about that in detail. All right, so now I just want to quickly jump into a presentation to show visually some of the stuff that we've been, discussing here on what it actually looks like. Okay, so basically, you've kind of like heard us talk about many different things here, Pulse, Data Hub and HiveMQ Edge. So maybe some of you are not really familiar with this product ecosystem for HiveMQ, but basically what we believe is the data maturity path for data centers is kind of like broken down it into these 3 layers. Where first layer is that you need to sort of like it's data streaming layer, where basically what we're saying is digitalization first, all paper-based operations, all legacy protocols. You do the digitalization, and sort of like turn your data into data streams that you then push into your infrastructure. So this involves that gateway that does the protocol conversion, and then this is also the MQTT plane where you're converting from OT protocols to MQTT. You're performing all of this governance and also using Data Hub, for example, where you're checking against the schema so that you know that all of the data that is coming from your systems, when it gets downstream, it is already formatted in a way that you are expecting. And then the second layer is the data intelligence layer, because now you're getting all of this data that is, in many cases, raw tags from Modbus or Office UA, and then you're converting them to MQTT. But for that to be usable for analytics or really to drive intelligence within your operations, you need to sort of like enrich this data. This kind of goes back to this idea of semantic enrichment. It's either through a semantic hierarchy, the unified namespace, where you're organizing your data in a way that is easily understood, right? Where it actually mirrors how your organization or your data center is arranged. You can quickly see all of the data assets across all of the equipment that are producing data across your entire data center operations just by understanding the semantic organization or the semantic layout of your organization. And then on top of that, you then have this layer that allows you to perform some agentic AI, or you've got like this orchestration where you're sort of like defining the guardrails on exactly what the AI agent is allowed to do and what it is not allowed to do. And in cases where you also want to have that sort of like feedback loop back into your OT infrastructure, you want to have that layer that gives you that operational safety. So these are the different sort of like layers that we see as the data maturity path that you need to take as you sort of like modernize your data center operations. But before we sort of like look at the architecture, or that architecture, what it looks like for you to be able to future-proof your data center operations, let's take a look at what Ryan was really describing earlier on here, where we're talking about the current landscape being this point-to-point data integration, whereby you've got all of your sensors, your chillers, your power systems that are sort of like sitting behind some gateways that sort of like expose that are a BACnet interface, Modbus, SNMP, or it may be an IoT gateway. And for you to be able currently for you to be able to get all of this data, you need to sort of like maintain some direct connections, point to point connections to all these gateways or directly to these sensors. And what this does is really, again, going back to this idea of polling, where for you to get data from an IT system, you need to poll all these different systems and sort of like interrogate them to get the data that you need. Now, this in effect introduces that latency, because in some cases this polling, it is done maybe batch based approach, where you're doing that maybe 10 minutes, or in some cases where data is only collected maybe after an hour. It doesn't give you that real time ability to inference and optimize your energy and whatever it is that you're really optimizing, because you really need that millisecond latency for you to be able to sort of like respond in real time to changes within your operation environment. And again, we spoke about this idea of having this fragile connection, whereby you've got a server that exposes data point, but it can't really handle the scale of the data that you want to be able to collect and move, whether you're serving your hyperscalers, your customers, or just for your own consumption to monitor the operation of your data center. That ability to guarantee uptime of the data is very crucial, because as you want to depend on this data, you want to make sure that you always have that data availability all of the time. And also, not to mention that this also really creates data silos. Again, if you look at data, we spoke about this idea of having this graph data model where everything is connected. If you are looking at a piece of equipment, you're not looking at it in isolation. You're actually looking at who actually was operating on this piece of equipment, right? And all of this context around it. So if you've got this point-to-point connection, what that means is that this data is actually living in all these different systems as silos. You're not looking at it in context, in the full context that you really need to make decisions, data-driven decisions. And you've got this limited visibility. And more importantly, this is what I see, for a lot of customers where if you have a use case, say energy optimization, you need to create a set of connections to all these source systems where you need to get the data. If you have got a use case number two, what that means is that you repeat that same effort of setting up that connectivity infrastructure because you're setting up infrastructure per use case. So there's redundancy in the way that you're sort of like addressing all of these different use cases. And again, this doesn't scale, and this is the reason why some projects end up, taking some years, and even months more than it should actually do, right? So, and again, Ryan, please feel free to jump in if you've got
I
information.
just want to double down on that point, Kudzai, because if we just look at the graphic you've got here on screen, in this scenario, what I have to do if I'm operating the data center and I want to improve, or I'm architecting my next data center I'm going to build, for my DSIM system, I have to understand potentially 3, 4, 6 different systems. And I have to go find each individual piece of data from each of those things. Or if I'm the BMS system, I've got to go get all of that data from all of those individual systems. And those might talk different protocols. So your implementation cost and the engineering complexity around creating, this web of connections and information is incredibly expensive, not just to implement the application initially, but to troubleshoot and diagnose and deal with issues that you have in production. We all like to pretend those will never happen, but when you're trying to solve problems on the stuff and you've got a system down and the pressure's on, it would be really great if you had something that was clean enough to where there was a one-stop shop for all of these systems on the right-hand side to go, and a one-stop shop for all these systems on the left-hand side to publish to. So you don't just get the efficiency benefit, you get the maintenance and sustainability and the application building benefit as well.
100%. So, I mean, talking about one-stop shop, let's move on to what that, one-stop shop actually looks like. So basically, how do you solve, these challenges that we have already spoken out? The first really, primary, architectural approach here is to decouple those point-to-point connections. And effectively, what you're doing is you're replacing all these multiple connections with a central hub, right? So basically, all of your systems are connecting into infrastructure. So you're not connecting applications directly to devices. You are plugging your applications and devices into a common infrastructure. So again, this goes back to the idea that you're not ripping and replacing. Rather, you're creating this abstraction where you're collecting data, publishing it into infrastructure from the OT, and then you're collecting data from IT, publishing it into that same infrastructure. And then what you then do with that is that you're creating a unified view of your operations across both divides, right? You're not only just looking at OT data, but you're looking at IT data in the context of OT and OT data in the context of IT. And here, this is the clean data, contextualized data, and then semantically organized in this manner. And it's all into MQTT. And the first big piece of it is that you're now moving away from this polling-based mechanism that we spoke about into an edge-driven architecture, whereby a change at the edge, a change in the status of your cooling system is instantly reflected in the infrastructure, in your data infrastructure. A change in the power consumption is immediately reflected in the data infrastructure. So you don't have applications reaching out and asking about this, the status of your equipment. Rather, the state is actually being published from the edge. And then what does it creates this single source of truth whereby just by connecting to your MQTT broker, connecting to your unified namespace, you're able to get the current snapshot of your entire operations. You're then able to build your business model around that because you've got the trusted source or single source of truth. If I'm an analytics system, I don't need to know 100 or 200, direct connections to all the data sources that I need data from. I only need to know that one endpoint, the MQTT broker, and then I can find all the data that I need to be able to, build all the different use cases. And this really goes back to this idea that we spoke about, that for each use case, you are reusing the same pool of data, right? Because your data has already been contextualized, cleaned. If you've got an energy optimization use case, you're plugging into the same data infrastructure. If you've got, another use case, you're plugging into the same data infrastructure. So that's a significant, cut in the amount of implementation that you have to do otherwise, just to address different use cases there. And also what this does is that now you also, because it's an open ecosystem, right? It's not a vendor logged system whereby you can only get access, or you can only plug into it only if you support that protocol interface. What that open ecosystem means is that you're able to choose all the different tools, like best in class tools, to address whatever problem that you want to address. For example, if you've got ignition that you're using at the edge to solve specific problem, it simply plugs into that MQTT infrastructure. Or if you've got HiveMQ edge that you're connecting to it, it plugs into that common infrastructure. So the advantage of building that common infrastructure, that is more and more applications can start to plug into that same thing, whether it's a DCIM, a BMS, all these other different systems, they plug into that same infrastructure. So I'm going to move on to the next section here, just to show you, from the HiveMQ point of view, how do you actually get, that data, practically speaking, to a point where you're able to move it into that common infrastructure. So I think we spoke about this idea that we have got HiveMQ Edge that provides OT connectivity with the different protocol adapters. I'm going to show you what that actually looks like in the demo that I'm going to show you shortly, where you've got all these different protocol adapters for different systems, and then you've got an embedded MQTT broker within there that allows you to already organize the data within that sort of like edge environment, and then you push the data into a site broker that is sitting at your data center site, that is providing all the security and reliability and scale of moving data that we were talking about previously. And then if you happen to have many data centers, you can then have that one broker, enterprise broker, that is consolidating data from all these different brokers, and it is that get sort of like gateway into your analytics or your business applications. If you need to persist the data into your Azure Analytics, you need to go into Kafka or whatever, Power BI or whatever systems you've got downstream. This is where you then are able to use the extension ecosystem to move that data onto your systems. So this is basically what it looks like if you zoom out, where you've got a HiveMQ Edge, which effectively is it's a connectivity software that can run on devices as small as a Raspberry Pi. So technically, you can really put this in a cabinet, in your control cabinet, or you're using an edge gateway. Whatever device you're running it on supports all the containerization approaches. And then on the HiveMQ platform side of things, it could either be you have your self-managed or fully managed, but this is all really just one platform right now. But this is where you have all of the functionality for your extension ecosystem, where you're able to then push this data to your databases. As you can see, we support MongoDB, Postgres, Snowflake, Databricks, and all the different data platforms where you'd want to move that data to, or if you want to stream it into Kafka or Azure event hubs and things like that. And then this is also where you're able to also implement some security on top of your MQTT infrastructure, whether it's LDAP or whatever you're supporting within your infrastructure. So now, just want to talk about some use cases. I think Aaron asked about customer case studies. So these are actually real customers. So as I mentioned, if you want to get more details about who they are and more details about these use cases, please feel free to reach out. We'll be more than happy to talk to you about this. So basically, as you can see, use case one really is about how do you provide real-time sharing of IT and OT data to customers, right? So monitoring the fuel, the diesel tanks and things like that. And then on use case two, we've got data center health monitoring. So to monitor the health of your data center assets. So that means collecting data from your electrical, mechanical telemetry, power, voltage, and airflow chillers, and all the switchboards, and then moving that data into a data analytics platform for you to be able to, monitor the health of your data center. And then we've got the power grid efficiency monitoring. So basically using HiveMQ as that backbone that allows you to, build your power grid efficiency monitoring solutions on top of, because you've got all of that data that has been consolidated from all your assets across your data center, and then you're using HiveMQ as that data backbone. So now let's talk about, what are the, again, this is so for from one of the customers on the actual outcomes that they, got from that. So as you can see, we spoke about the issue of polling. So they used to have this 15-minute window before they could get some updates. So this was really, cut down to those real time as and when it happens, whether it's within the millisecond or within the second, to get all of that data. And then they got that 5x faster data delivery. And then for those of you who have been sort of like wondering about the scale of the data that we're talking about here, so as you can see here, they managed to move 1.8 billion messages per day that they're pushing from a single site. So this kind of like give you a sense of the, the scale of the data that we're talking about. And then what that led to, as far as outcomes are concerned, is 70% fewer outages. All right, so maybe Ryan, if you've got something to add there, while I, jump into more of a reference architecture to show what that, reference architecture looks like.
Yeah, while you pull that up, I think I'll just kind of reiterate here the benefit of being able to drive really high resolution data in terms of per unit time. We've got customers with data centers that have millions of data points that are transmitting once a second. And again, there's active management through a BMS and a cluster management system that's actually pushing commands back into the control systems in the data center on as you pointed out, a 15-minute polling architecture. You can't respond in real time with that infrastructure. And so what you're able to do in terms of efficiency and control and one way this works out for data centers is you ultimately need, if you can balance all of these loads in real time, you need less power going to this data center, right? Because you can balance those loads over time to get more effective energy usage out of it. So there's all sorts of opportunities that come from the real-time visibility into all of the data.
Oh, yes, absolutely. All right, so just give me a thumbs up, Ryan, if you can actually see my reference architecture on the screen.
There you go.
Okay, 100%. All right, so this, kind of like gives you an example of what, the layout of the different components or the different architecture looks like. So as you can see on the left-hand side there, we've got the, the racks, telemetry, we've got the heat pumps, and then we've got the sensors and all the different power systems. So again, this could be, going through a PLC or directly, connected to say a HiveMQ piece of infrastructure. So in this case, you can see we're connecting to OPC-A via OPC-A to PLCs. But again, HiveMQ Edge supports different protocols, Modbus, which is very popular in data centers. You're able to connect to those using Modbus. And this, what you see here, is HiveMQ Edge that is providing that connection. So if I actually go into, okay, just a second. If I actually go into HiveMQ Edge interface, this is what it looks like. So again, here you can, okay, I need to try and back in. You can see there's different protocol adapters here. So you can add a new adapter. We've got Modbus running here, and then we've got OPC running. You've got Modbus adapter, and then you can select from many different protocol adapters that you want here. And then we've got an MQTT bridge, basically that allows you to then take this data that you've converted into MQTT and then push it into a HiveMQ broker that is sitting either on site at a data center or is sitting somewhere else at a remote location. So again, here we've got a lot of different functionality. Data Hub, we mentioned this idea that you're able to then enforce a schema if you want that data to sort of like conform to a certain format before it actually hits your downstream systems. And then there's just so much more into HiveMQ Edge here. And then on the broker itself, which is sitting right here, where your edge is moving this MQTT data to the broker, and then the broker, this is where typically you're connecting your BMS systems, you're connecting your DCI systems. This is also where you are connecting your ignition SCADA system. So they're all consuming all of this data that is coming from the edge and then pushing that data back into that broker. So this is what you'd call that local unified namespace. But that concept of a local unified namespace also goes away with HiveMQ Pulse, because HiveMQ Pulse then sits on top of all of these infrastructure. You don't have to have these fragmented unified namespaces scattered all over. You've got this one semantic namespace that you are managing, that you're looking at, that you're sort of like consuming off of and enforcing. And then here we've got the broker that is sitting in the cloud. And by the way, you are able to also connect your extensions from this site broker. But depending on your architecture, you can push this data up to this central data aggregation point, where you're then connecting to your data platforms, your Snowflakes, your Grafana, Postgres, and the likes. And then just to give you a sense of what the control center environment looks like. So this is where you're then able to manage your MQT platform. So as you can see, you've got these installed integrations currently that are we're connecting to. We've got this Kafka connection. So this is where you're able to then set up your integration points. You're able to manage the health of your sort of like connections to see exactly how much messages going through, how much subscriptions are currently there. So this hopefully gives you a picture of what a real world implementation for some of our customers on how they're actually connecting all of their data to this MQTT or unified namespace infrastructure to create this data-driven backbone. So if there's nothing to add here, Ryan, I'll sort of like jump into the Q&A to see if we've got some questions.
Yeah, absolutely.
Okay, so Alan, it's asking a really great discussion. Thank you. Is there a way to simulate or prove the value of this approach without necessarily having access to physical data centers, that is virtual environments or test beds where the technology can be played with? You want to answer that one, Ryan?
Yeah, absolutely. The answer is absolutely. We do simulate these things. So we've got, and that comes in two forms. We do simulation. It's a service that we provide to our customers as we take on implementing these data center projects, where we will do stress testing, which is less simulating real world, but more simulating worst case to validate that things are doing what they need to do, and then also simulating real world. You could think of it like a digital twin. We're not building a functional model of the data center. We're replaying data so that we can test and validate those workflows. But without that testing, we wouldn't be able to do high-speed iteration and development. We wouldn't be able to build applications at the speed that that the construction demands of these new data centers look for. So absolutely, we prove these things out before we go to implement them in a physical space.
Oh, yes, absolutely. So I think, so Reginald asking, will the slides be made post-event? Yes, they'll be made available as well. So just to put you on the spot here, Ryan, with a few questions of my own here. So what is usually the triggering event, right, for a lot of customers that come to you? Like, at what point do sort of like operators realize that their current approach is no longer working? Is there usually sort of like a, a triggering event that sort of like gets the conversation started?
Yeah, I think with a lot of it, it's in the large and hyperscale um, grade data centers, and you look at what the infrastructure cost and what the infrastructure complexity is going to be in the old way of doing things, and that immediately triggers a conversation to go, hold on, we need a better way to do this to work at scale. I would say that's the most common realizations. They start that sort of initial. Um, it's not blueprinting, but it's that initial, whiteboard sketch, do the thing. You start thinking about it, and uh, the very, very large mountain of the infrastructure you'll have to implement says, okay, we've got to think about this a different way than we have in the past.
Yeah, absolutely. So if you were to sort of like give us a playbook on so data center operators who are watching this right now and say, okay, how do I go about this, right? What the realistic and more practical playbook from starting from zero to getting to a point where they're now a more data-driven organization?
Yeah, absolutely. I think first is it's always helpful to sketch sort of the worst case scale, and I say worst case, but largest case scale, right? What's the biggest that we could expect this to go to? And while a lot of, especially Hive and Q solutions, you can continue to scale horizontally really easily. Um, there's a lot of decision making that can save you a lot of time, energy, and effort if you're not hitting a scale that starts to become cost prohibitive. So set the scale, understand what your sort of max scale might look like. From there, start defining a strategy for how you're going to uh, define this graphical and semantic data model, and come up with an architecture strategy that will enable you to scale. Right. So, you were showing an example of a particular architecture. Sketching that out, identifying what points are going to uh, where are we going to get from Modbus to MQTT? Where are we going to get from OPC-UA to MQTT or S7 or whatever protocol it might be? How is that going to horizontally scale? How many of those do we need? And then where does the data need to go? Would be the next place. Is this all just local to a site?
Yeah.
Are we trying to drive this to HQ? And you start to map things out there. Um, and then when you get into implementation and you really start doing the project, um, uh, I can't stress enough scalable deployment methods, testing ahead of time, like we've talked about,
Mhm.
doing effective CI/CD so that you can have a test environment that's truly representative of your production environment. And that allows you to build these applications fast enough so that when it's time to turn everything on, these data systems are enabling speed, not the blockers to construction continuing on the data center.
Oh, yes, absolutely. So I think we've got a couple more questions here, but I think these two can actually be put together. The one from G. Vikram and Matthias Rocha. Basically, it's more around security. So Vikram is asking which components of HiveMQ must be installed at DMZ zone where data is streamed to internet. And Matthias is asking with IT/OT convergence and cybersecurity, where does the broker typically sit in terms of the Purdue model? So you want to speak to that?
Yeah, as far as which component of Hive in Q would be installed, behind or in or on the outside of the DMZ, there's lots of architecture options, and it depends on your security model. Um, I think if you've got to stream data over the internet, still encrypted, right, you're probably going to put some probably the data hub or pulse type entity that's just consuming a portion of that UNS of what's being streamed into that MQTT broker and pushing directly to whatever service needs to go to, and MQTT is a great opportunity for that. But I would just highlight the flexibility on the HiveMQ side for where you put HiveMQ Edge, where how you leverage Data Hub, and then the ability to bridge between brokers allows you to comply with any kind of security requirement in terms of the architecture on that side.
Awesome. Yeah. So there's another question from Matthias, who's asking, what does the OpEx look like for this? While beneficial for developing at speed and scale, how does this look cost-wise, day two? You want a sense of what that OpEx look like?
Yeah, that is really dependent on the operators, the co-locators, and what they're doing with the data center and what they're asking the systems to do. Realistically, because OpEx model for HiveMQ's cost would be one thing. I won't steal that from you, but in terms of the applications, it's really about enabling building an application that can run with the data center. And so that development should be done by the time we're at day two.
Yeah.
Right. We're trying to give those operators the tools and the information they need on a day-to-day operational basis. That application shouldn't need additional development after day two.
Oh, yeah, absolutely. So, Matthias, please feel free to reach out to us. I think we'll be able to give you a much more detailed breakdown of the, from HiveMQ side, what that, could look like. So, more than happy to provide that. We've got Yash who's asking, for the ignition side, we currently use SiriusLink. Could you clarify what additional value HiveMQ would provide beyond our existing setup and how it would enhance the overall architecture for performance? So yeah, I mean, I think I'll kind of like just speak a bit to that, and then Ryan, you can chime in there. So I mean, there's different architectures altogether that well, not different architectures, but just the broker or the platform architecture itself. So HiveMQ supports clustering, right? Which basically allows you to create these multiple nodes within your broker cluster that expose that one logical endpoint. This is basically what customers really love about that, because then it gives you that high availability and reliability for your broker. Because once your broker becomes that core backbone, your critical infrastructure, you want to have that guarantee that you're not going to have even a single message loss, right? And then you're also going to have this high availability sort of a platform being your data infrastructure. So I think this is where mostly people that sort of like move from SiriusLink or some other brokers to a more critical infrastructure platform as E-Twin.
Yeah, I think I'll just highlight, it's no secret that Vertec does a lot of work with Ignition. And so we've got a lot of situations with our customers and projects we're doing where, Ignition is one of those, whether it's Edge or a standard edition, is living as one of those edge communication devices. And we're using SiriusLink's transmission modules to push into an HiveMQ MQTT broker in the center, and may even have some other scenarios where in that same architecture running HiveMQ Edge to also communicate to some devices and push up, because that environment for other reasons already needed the other benefits of Ignition that were there as a SCADA system. And then on the broker side, if we're talking about the MQTT broker, because I mentioned about the clustering and just the scale. HiveMQ can scale to the largest of loads that you would need from an MQTT broker. But completely different from the offering from SourceLink is things like HiveMQ Pulse, where you're adding this semantic modeling and information and context and enriching the data, and then providing the visibility to all of that data. Is a completely additional value benefit that doesn't come with just an MQTT broker.
100%. All right, I think with that, we actually right on time. So thank you so much, Ryan, for joining me on this session here today. And thank you to our audience for taking the time to join us here. So as mentioned, the recording will be available. And if you've got any further questions, please feel free to reach out to HiveMQ, or you could reach out to Ryan, and then we'll be happy to answer your questions. So thanks again, and have a great day.
Great. Thanks, everyone. Thanks, Kudza. I really appreciate you having me on.
Thank you.